guys, welcome once more to class online. My name is Dami, and in this edition we shall look at Jamb Physics 2013, question number 16 to number 20, and we shall be taking some quite problematic part of physics in this edition. One of such is, why is it that salt water boils things faster than normal water? Like what I said is that if you put a piece of meat into salty water, that meat will cook faster than cooking it with pure water. And one of that, we will have to explain that. Now also we will touch other part of physics that has to do with thermal physics and has to do with linear expansivity and so on, and also one that has to do with temperature. So don't forget that if you learn something from this series, click on like button. We have lots of content to send to you that will better help you understand physics. Now let's get to the question right now. Number 16 says, calculate the length which corresponds to a temperature of 20 degrees Celsius if the ice and steam point of an ungraduated thermometer are 400 millimeters apart. Now, what is the length that will amount to 20 degrees? Now, this question is a thermometer question. Now, all thermometer questions are solved the same way in physics. Whenever you see the word temperature, thermometer, it is one-way question. And if you get what I solved now, you'll be able to blast any question from Jamb on temperature. Now, this is it. This is how to go about it. Now, you know that we were told, find the we have this is the question thermometer. The gap between the interval, that's the ice point and the steam point of that thermometer, is between 400 and 0. Okay, that's the maximum is 400, the minimum is 0. Okay, now let's call this one my own thermometer. That's the one in the question. But this one, I call this one the standard thermometer. Okay, this is the standard thermometer. This is the one in the question thermometer, standard thermometer. Now 400 millimeter, okay, is the maximum of the standard, because it was said between the ice and the steam point is 400. So that means 400 to 0 gap. Okay, now what will now be the one in the middle? For if the standard thermometer is at 20 degrees Celsius, you know, we know that the highest point of a standard thermometer is 100 degrees Celsius. Then the minimum point for the normal body thermometer is 0 degrees Celsius. So that means the highest point is 0, that's for water, and the maximum point is 100, that's for the boiling point or the steam point of water. Now, but what will now be 20 degrees Celsius in the question? That's in the question thermometer. What will it be in millimeter? That's in the second thermometer. This 20 degrees Celsius, what will it be in the question thermometer? So how we do it? This is the way to set up any question on thermometer. They will always give you one, okay, of the question, the one for the question, and they will say, and they will give you one for the what? For the standard. For the standard, they will not give you 0 and 10 and 100. You will know that on your own. They will only give you the ones in the middle, or say find one of the ones in the middle, and they will give you the maximum and minimum for the question thermometer. So now in that case, this is how to set it out. Now the first thing to do is to say from the middle here, x minus 0, that's x minus 0 over 400 minus 0. That's the way to set it out. X minus 0 from the middle over 400 minus 0 equals the same thing here, 20 minus 0 over 100 minus 0, and that is the first mark. Now x minus 0 is x, 400 minus 0 is 400, equals 20 minus 0 is 20, 100 minus 0 is 100. Then you cross multiply. Okay, that will give me 100x equals 400 times 2, giving me 100x equals 800. So dividing by 100, I will be having 800 divided by 100. That's what? 8 millimeter. And that is the answer to that question. The answer to that question is actually 400. What I have here is 400 times 20. Oh, so sorry. It should be 400 times 20. That means 8,000. 8,000 divided by 100 is 80 millimeter. And that is the answer to that question, 80 millimeter. Please take note. This is the way to go about solving the question, from the middle down, then the maximum down, then middle equals middle down, then maximum down. That's the way to go. Now, number 17 said a wire of length 100 meter at 30 degrees Celsius has a linear expansivity of 2 times 10 per minus 5 per Kelvin. Calculate the length of the wire at a temperature of minus 10 degrees Celsius, right? Now, this question is on expansivity. Now we know that the main formula for expansivity is linear expansivity formula, right? And that says that was change in length per change in temperature, and that is the formula. Anything expansivity linear is this formula. That's the change in length, that's difference in length, L2 minus L1 over L1 times theta 2 minus theta 1. Please, theta 1, not theta 2. Theta 2 minus theta 1. Now, what is my change in length? Now, the equation says calculate the length of the wire at temperature of minus 10 degrees Celsius. Then find the second length, because we have been given a length here. Now we have to find the L2. So I'm finding the L2. The first thing for me to do is to make L2 the subject of formula, and that is where my answer begins. Now I'll just cross multiply. Solving for L2, cross multiply. So L2 minus L1 will come down. That will become L2 minus L1 equals linear expansivity times L1 times change in temperature. That's theta 2 minus theta 1, and that's what I have here. Okay. So I've multiplied. Now I have to make L2 stand what? Alone. So I will remove this L1 from here and jump it over to the other side to become positive. That will become L2 equals linear expansivity times L1, then times change in temperature plus L1, and that is it. I have manipulated the formula and make L2 the subject of formula. The next thing for me to do is to plug in the parameters. Now, what is my linear expansivity? It was given to me the question, right, as 2 times 10 raised to the power minus 5. So that's it here. Then my L1 is 100, okay? Then change in temperature, theta 2 minus theta 1. It was initially, it was the final temperature is minus 10 degrees Celsius, right? So that will become minus 10. Then minus the initial temperature is 30. That's minus 10 minus 30. Then plus 100, giving me 2 times 10 raised to the power minus 5 times 100. That's 10 raised to the power 2. That's 100. Times minus 40, okay, because minus 10 minus 30 is minus 40, and that's minus 40 plus 100. Now solve all these ones first. So I will now punch 2 times 10 raised to the power minus 5 times 10 raised to the power 2 times 10 raised to the power minus 40, and times minus 40, and that will give me minus 0.08 plus 100. If you punch that, you'll be getting 99.92 meter, and that is the second length you are to find. Don't forget that everything came, and that means option D, the answer to that question. Don't forget that everything came from the formula of linear expansivity. I only made L2 the subject. That means the second length, the subject. I did nothing more. Then I plug in all the parameters and I got my answer. So that is how to solve this question on linear expansivity. Now let's check out number 18 now. Number 18 says a gas at a pressure of 10 raised to the power 5 Newton per meter square expand from 0.6 meter cube, that's per meter cube, to 0.5 meter cube. That should have been meter cube, not per meter cube, at constant temperature. The work done is what? Now you can see all these gas cylinders. When we go to fill our gas at home, when your gas gets finished and you want to fill it, they have to consider pressure. So because the person filling it can't see the gases, and also volume. So volume of gas is a function of its pressure. Now let's see. But this question is asking that what is the work done? Okay, when this gas was expanding, it expanded from this volume to this volume. What is the work done? Now the big question is, what is the relationship between work, pressure, and volume? And what formula can help us to show the relationship? Do you have any idea which one might be right? Now actually, the formula is this: work equals force times distance. What does pressure have to do with this formula? You know, when we were in year 1, we were taught about work, energy, and power, and we were taught that force times distance is work. But do you know that pressure can come into this formula? Pressure can come out from this formula, and this is the way it comes. The pressure formula itself is force over area. So if you cross multiply and you make force the subject here, you have force is equals to pressure times area. And then if you now substitute that into your force here, you'll be having pressure times area times D. So that means that pressure times area is now standing for force. Pressure times area, that means force is pressure times area, because pressure is force over area. So if you make force the subject, pressure times area will now become the force. So therefore, I will now substitute for force pressure times area times D. So my work is pressure times area times D. But the question asks volume, and there is no volume in this formula. So how can I bring in volume? You must also know that area times length or distance is volume. What do I mean by that? You know, meter times meter is meter square, and that is for what? Area. But meter times meter times meter is what? Meter cube, and that's for volume. So meter square is for what? Area. Meter cube is for volume, and that is what we have here. Area has 2 what? Meters. Then d, distance, has 1 more meter, making 3 meters, and that means that it is volume. So these 2, area times d, will give me volume, and that is what I have here. So work is now pressure times volume. So I have turned this thing into pressure, volume, and work relationship, and that is now what I will use for my answer. Now, but I was given 2 volumes, so I will just substitute 2 of them in, and I will subtract them. I will find their difference. So to find the work, so work is now pressure times volume 2 minus volume 1. Okay, so my volume is what? My pressure is 10 raised to power 5. The first volume is 1.2, second volume is 0.6. If you minus, then you'll be having 0.6 times 10 raised to power 5, and that will give you 60,000. But you can now make it to be in standard form. That will become 6 times 10 raised to power 4 joule. And why is it 10 raised to power 4? It is because there are 4 zeros. 1, 2, 3, 4. So in 60,000 we have 4 zeros. That's 6 times 10 raised to power 4 joule, and that is the work done in that system. It all has to do with the same formula of work, but changed into pressure times volume, and that means that my answer is option D for number 18. Number 19 says 2 liquid X and Y have the same masses as supplied. Having the same masses supplied with the same quantity of heat. If the temperature rise in X is twice that of Y, the ratio of specific heat capacity of X to that of Y is what? Now, what is the relationship between heat and specific heat capacity? What is the relationship between heat and specific heat capacity? Now, you will know that this is thermal physics, right? Now, you know that the formula for anything thermal, when you hear the word heat, it is H equals MC change in temperature. But this question is between heat and temperature. You can see if the temperature rise in X is twice that of Y, that means temperature first, then what will now be the specific heat capacity? Now this H means heat, M is what? Mass, and C is what? Specific heat capacity. Y theta is what? My temperature. Okay, now so this question is between specific heat capacity C and temperature theta, and that will become C. But if you look at this formula, C and theta are on a straight line. That means they are linear. That means C is directly proportional to theta, and that is it. Now, and that is their what? Their relationship. So if you put in a constant here and you divide both sides, you'll be having CX over CY equals theta X over theta Y, and that's what you will use to solve this question. But they say that for the first one, specific what will be the specific heat capacity of X to Y? So, but we were told that the temperature of the temperature rise between X and Y is 2:1, right? If the temperature rise in X is twice, so X is twice and Y is 1, is single, then what will now be the specific heat capacity of X to Y? It will just be the same, and that will become 2:1, and that will be my specific heat capacity, and the formula is just 2:1, because the reason is because specific heat capacity and temperature are directly proportional. So whatever happened to the first will happen to the second. So if the first one, that's temperature, is 2:1, that means that is that the specific heat capacity also will be 2:1. Because why? Two of them are directly proportional. That means that whatever happened to this one will happen to this one. So if temperature is 2/1, then C also will be 2/1, and that's why the answer is 2:1, and that is the answer for number 19. Now let's go to number 20, that has to do with why salt water cook food faster than pure water. Now, food cook quicker in salt water than in pure water because of the effect of what? Now there are some explanations that we need to know here. Now number one says dissolved substance on the boiling water. Is it because of dissolved substance on the boiling water, or atmospheric pressure on the boiling water, or food nutrients on the thermal energy, or salt on the thermal conductivity of water? What effect causes salt water to boil faster than pure water? Now let's take a closer look. Food cook faster at higher temperature. Boiling salt water occur at a higher temperature. You can see this pot and the water bubbling, right? Boiling. Now, boiling salt water occur at a higher temperature than boiling water. So when food is cooked in boiling salt water, we are simply boiling food at a higher temperature, causing it to cook faster. So now this is the explanation. Salt water, before salt water can boil, it takes a higher temperature than the higher the impurity. Salt in water is an impurity, so an impurity raises the boiling point of water. That means natural water, pure water, will boil at 100, but if there is salt in that water will not boil at 100 degrees Celsius. It will boil at maybe 105, because impurity, which is salt, causes water to boil at a higher temperature. That means I am saying that it is more difficult for water to boil if the water is not pure. So if the water is pure, it boils at 100 degrees Celsius. That is normal. But if it is not pure, if it has salt, it boils at a higher temperature. Now impurities make it difficult for water to boil, and that's it. So the salt water is hotter than the pure water because the temperature of the boiling salt water is higher than that of pure water, because before the salt water can boil, it has gone through higher temperature, higher heat, before it can come to boiling point. So that means the temperature of the salt water is higher naturally than the temperature of the pure water. So if you put something inside the two pots, that's one has pure water and one has salt water, the one that meat you put into the salt water is boiling at a higher temperature than the pure water, and that's why the meat in the salt water will boil faster. It will cook faster than that in the pure water, and that is the reason. And it is because of dissolved substance. It is because of the effects of dissolved substance, that's salt, on the boiling point. The effect of dissolved substance or salt on the boiling point is that it has raised the boiling point, and that's why it has also raised the temperature of the water, and that's why it will cook faster, because of the raised temperature. And that is the answer for number 20. And that brings us to the end of this video. Don't forget, if you learned something from this video and you want to get more content from us that will better help you understand, click on like button and we'll get to send some very nice content to you that will better help you understand. Until we see again, guys, take care of yourself and bye for now.